Good day and welcome back to my channel. In the previous videos, we looked at derivatives from first principles. In this video, we will look at how to do short differentiation. In the previous video, we used the notation f prime of x, which means the derivative of f of x. These are alternate notation that's also used. This notation means the derivative of y with respect to x. This means the derivative with respect to x, and this notation means the derivative of the equation y is equals to. Basically, all of the above notation means derivative. Now, in order to perform short differentiation, there are some rules that we need to follow. The first rule of short differentiation is the derivative of a constant. So the derivative of a constant is 0. Here, if you look at f of x is equals to 4, the derivative of this function is 0 because the derivative of a constant is 0. The second rule of short differentiation is if the function contains an x, the derivative is everything besides the x. So if you look at an example 7x, the derivative of the function 7x is just 7. Because to find the derivative of a function that just has x to the power of 1, we remove the x, and that's how we get the derivative. Rule number 3 when it comes to short differentiation is for x to any exponent except 1 and 0, we multiply the exponent with the coefficient and then we subtract 1 from the exponent. If we have f of x is 4x squared, according to our rule, we take the exponent and we multiply it by the coefficient. So 2 times 4 is 8. And then we subtract 1 from the exponent. So x to the power 2 becomes x to the power 1. So the derivative of 4x squared is just 8x to the power 1, which is just 8x. In the second example, our function is 12x to the power negative 3. So according to our rule, we take our exponent and we multiply it by the coefficient. So negative 3 multiplied by 12 is negative 36. And then we take our exponent and we subtract 1 from it. So x to the negative 3 becomes x to the negative 4. The final rule that we use in grade 12 differentiation is the sum and difference of two differentials. So basically, the derivative of a sum is the sum of the derivatives. And this will make more sense once we do an example. But this rule also applies to differences. The derivative of 4x plus 3 is the same thing as the derivative of 4x plus the derivative of 3. And from there on out, we can use our rules 1, 2, and 3 to find the derivative of this. Now, let's look at some examples. The first example, f of x equals to 6. Now we know 6 is just a constant. So if we apply the first rule of differentiation, which is the derivative of a constant is 0, then the derivative of the above function is just equals to 0. All right, let's look at a second example. F of x equals to 8x. Now, 8x is just x to the power 1. And if we look at our second rule of differentiation, the derivative of any function with x to the power 1 is everything except the x. So the derivative of 8x is just 8. Right, let's look at a third example. If our function is equals to 2x cubed. Notice we only put in the derivative notation once we do the derivative of the function. So, example 3 is an example of the third rule of differentiation, the power rule. So, just to recap, we take the exponent and we multiply it by the coefficient. So, 3 times 2 is 6. And then we remove 1 from the exponent. So x to the power 3 becomes x to the power 2. This is a bit different from the ones we've been doing before. But if we apply the fourth rule of differentiation, which is sum indifference of derivatives, then the derivative of this sum is the same thing as the derivative of each term individually. So we'll use the first three rules of differentiation to derive each term individually. So the derivative of the above function, now let's look at them term by term. The first term is the power rule, or the third rule of differentiation. So we take the exponent and we multiply it by the coefficient, so 4 times 2 is 8, and we subtract 1 from the exponent, and we're left with x to the power 1. Right, plus. Now, the second term, we can apply the second rule of differentiation. So the derivative of anything with x to the power 1 is everything except the x. And then finally, the derivative of 1 is the same thing as the derivative of a constant, which is 0. So to simplify this derivative, so the derivative of 4x squared plus 3x plus 1 is simply 8x plus 3. Join me in the next video where we look at more complex short differentiation problems. If you enjoyed this video, give it a thumbs up and subscribe to my channel.